What if the sky is trying to remind us of something we were never meant to forget? New observational data reveals that Comet R2 SWAN has developed an unexpected sunward-facing tail, mirroring the puzzling behavior once recorded in the interstellar object 3I Atlas. And now, both bodies trace orbital lines that appear to circle Earth with a precision that feels less like coincidence and more like intention. This moment invites us to reconsider our own origins, not the familiar chapters of humanity, but the forgotten epochs buried beneath hundreds of millions of years of geological silence. The possibility that prehistoric civilizations may have risen long before the dinosaurs existed is no longer merely the territory of myth. It emerges at the intersection of scientific anomalies, cosmic geometry, and unanswered questions that shadow our understanding of deep time. As astronomers study the strange luminosity of R2 SWAN's sunward tail, they find themselves confronting patterns that resemble those seen in 3I Atlas before its fragmentation. Two objects from vastly different regions of the solar system showing the same forbidden behavior challenges our assumptions about how comets interact with solar radiation. When their orbital paths are modeled together, an uncanny geometry emerges. Each body arcs around Earth in a way that resembles an ancient observational pattern, the kind sometimes encoded in prehistoric fossils or found in symbols carved into rocks far older than human civilization. These new discoveries push us toward a question many refuse to ask. Are we witnessing a natural cosmic coincidence, or are we glimpsing the remnants of a knowledge system older than the species that now stares upward? The mystery deepens as we examine the vast stretches of time before the rise of dinosaurs. Our planet has undergone cycles of creation and erasure so thorough that entire worlds could have flourished and vanished without leaving recognizable traces. If intelligence arose in these ancient epochs, it may have interpreted the sky as both a clock and a language, mapping celestial cycles that we are only now beginning to rediscover. The movements of R2 SWAN and 3I Atlas become more than astronomical curiosities. They become invitations to rethink the nature of planetary memory and the possibility that Earth holds forgotten chapters of its own story. Understanding these patterns is not just a matter of astronomy, but a doorway into a deeper comprehension of who we are, how long intelligence has existed here, and what messages might still be written in the stars. Before we continue, share your interpretation in the comments and join this exploration by liking and subscribing. Your voice strengthens this community of seekers, and your support ensures we continue uncovering the hidden history of our world. The new patterns emerging from the movements of R2 SWAN and 3I Atlas invite us to confront a possibility more profound than any celestial anomaly. When we trace their trajectories across the sky, something unexpected begins to surface. A geometry that doesn't simply follow gravitational logic, but seems to echo structures found in the deepest layers of the geological record. Layers that predate dinosaurs, mammals, even the earliest recognizable ecosystems. This is where Topic 1 begins, the impossible timeline, the realization that Earth's past is not a straight path, but an immense labyrinth in which entire epochs have been swallowed by tectonic fire, oceanic collapse, and planetary resets so complete that even their ruins were ground back into molten stone. To understand why the idea of prehistoric civilizations before the dinosaurs is not just speculative fantasy, but a scientifically legitimate question, we must first acknowledge how little of Earth's history we actually possess. Humanity studies the past through fossils and artifacts, yet both rely on preservation conditions so fragile, so unlikely, that nearly everything that ever existed has vanished. When paleontologists speak of the fossil record, they describe it as a window, not into history, but into what history allows us to see. And most of the window is sealed shut. Modern science admits that more than 99% of species that ever lived are extinct, but what we rarely reflect on is how many worlds vanished with them. When we look at the Precambrian, the vast expanse of time stretching billions of years before the Cambrian explosion, we confront a geological silence so deep that even our most advanced instruments struggle to decipher it. Entire continents formed and dissolved, oceans boiled and refroze, atmospheres thickened and collapsed. If anything living achieved complexity in those eras, the probability of its traces surviving today is statistically negligible. Yet certain anomalies stand out. Ancient mineral veins showing heat patterns inconsistent with natural processes. Isotopic signatures hinting at chemical manipulation. Fractured layers of rock whose geometric precision seems to resist random formation. Scientists often explain these away through natural mechanisms, because naturalism offers the safest intellectual refuge, but safe explanations can also blind us to rare truths hidden in plain sight. Imagine a world 700 million years ago, one caught between ice ages so severe that Earth nearly froze solid. If a civilization emerged within that narrow interval of habitability, its lifespan might have lasted only tens of thousands of years before the next global freeze obliterated everything. In geological terms, this is less than a heartbeat. Any structures they built would have been crushed beneath kilometers of ice and eventually recycled into the mantle. The deep oceans, which protected early life for billions of years, could have sheltered advanced species without ever allowing their existence to leave surface-level evidence. Even today, we continue discovering entire ecosystems beneath Antarctic ice sheets, thriving without sunlight, their biochemistry unlike anything found in familiar biology. This forces us to reconsider our assumptions about where life can evolve and how intelligence might emerge under conditions radically different from our own. But the impossible timeline becomes even more compelling when we examine the speed at which evolution can accelerate under environmental pressure. Studies of extremophiles reveal that organisms subjected to intense, fluctuating stress adapt at rates previously thought impossible. Genetic transformations that once seemed improbable over millions of years now appear under laboratory observation in mere decades. This raises the unsettling possibility that bursts of rapid evolution could create cognitive leaps in species we have never even identified, species lost to extinction so thoroughly that not even their molecular shadows remain. The timeline becomes less a smooth road than a fractured mosaic, in which intelligence could have flickered into existence again and again, disappearing each time the planet reset itself. Consider how humanity views itself today as the pinnacle of evolution, yet we have only existed for a vanishingly small fraction of Earth's age. If the entire history of the planet were condensed into a single year, modern humans would appear in the last few minutes of December 31st. Dinosaurs would populate the final days of December, but more than 11 full months of that cosmic calendar remain obscure, unwitnessed by any species capable of storytelling or record-keeping. It is within those 11 months that the potential for forgotten civilizations becomes not just plausible, but statistically favorable. Our difficulty is not in imagining these civilizations, but in accepting that we may never find their monuments, technologies, or written histories. We expect ruins made of stone, yet such materials would not survive 1 billion years of geological transformation. We expect bones, but bones do not fossilize without perfect conditions. We expect evidence shaped in our image, forgetting that intelligence is not constrained to build pyramids or cities or tools recognizable to us. It could have expressed itself in biological architectures, energy manipulation, or geological modification techniques that resemble natural processes to the untrained eye. This is where the orbital behavior of comets like R2 SWAN and 3I Atlas becomes symbolically relevant. Their synchronized anomalies serve as a reminder that the universe is full of patterns we do not yet comprehend, patterns that may intersect with Earth across cycles longer than any written narrative. In ancient mythologies, comets were interpreted as messengers of forgotten ages, not because they foretold doom, but because their appearances seemed woven into cycles older than civilization itself. Today, as we observe these celestial bodies behaving in unexpected ways, we find ourselves pulled back into that primal sense of cosmic significance. Not superstition, but recognition that patterns can hold meaning even when we lack the language to decode them. This impossible timeline forces us to confront a question that grows heavier with every discovery. If Earth has hosted civilizations before us, civilizations erased by time so completely that only faint signatures remain, then what does that imply about our own future, our own place in this vast chronology, and the hidden histories waiting to be uncovered as we continue to unravel the next layer of this mystery that leads us directly into the question of what the rocks themselves still try to tell us when we look closely and realize that the story we believe we know is only the first breath of something far older than the world we think we understand. something that begins to reveal itself when we study the fractured geological record, where time has tried to whisper but never quite finishes its sentence because the silence grows heavier the deeper we go. And now we step into what that silence might truly contain when we begin to explore what the rocks can't seem to say fully, when we realize that the past is never as quiet as it appears, when we listen to the next unfolding layer of this enigma and type 1 to continue or enter the changes you want. When we confront the fractured geological record, we enter a realm where certainty dissolves and the very foundation of historical knowledge becomes unstable. Rocks are often treated as the planet's memory, yet what they record is not a continuous story, but a scattered archive written in fragments, distortions, and omissions. The further back we travel in time, the more the pages crumble, until entire chapters vanish into metamorphic heat and tectonic collapse. This is the first great barrier to understanding whether civilizations could have existed before the dinosaurs. Earth itself is a poor historian. It preserves almost nothing from its earliest eras, and what survives does so by accident, not design. When geologists examine rocks older than 600 million years, they are not looking at landscapes frozen in time, but at remnants that have been shattered, compressed, melted, and rewritten by forces beyond our comprehension. These transformations erase not only organisms but all traces of structure, engineering, and activity. If a civilization arose a billion years ago, built monuments, shaped minerals, or altered its environment, all of it could have been folded into the mantle, erased in lava flows, or crushed beneath the pressure of continents colliding in cycles that repeat endlessly. Yet within this erasure, certain clues refuse to disappear entirely. They appear as anomalies, patterns in mineral alignment, isotope ratios that hint at unnatural heat exposure, magnetic signatures embedded in ancient rocks that suggest environmental conditions inconsistent with purely natural processes. These anomalies rarely fit conventional models neatly, and so they are often categorized as curiosities, geological oddities to be noted, but not deeply questioned. But scientific progress has always begun with the things that do not fit, with the fractures in the expected order. When we examine these anomalies not as isolated puzzles, but as part of a broader pattern stretching across vast expanses of time, the possibility of earlier civilizations becomes less speculative and more a matter of probability. The Earth has reset itself so many times that any advanced society predating the dinosaurs would have been erased repeatedly by volcanic floods, asteroid impacts, and the violent churn of plate tectonics. Consider the Canadian Shield, one of the oldest exposed rock formations on the planet. This region has endured billions of years of transformation, yet occasional findings, a geometric quartz vein running with unnatural symmetry, a heat-distorted mineral layer indicating temperatures far beyond what volcanic activity should produce, push researchers to ask whether natural explanations are sufficient. In Western Australia's Jack Hills, zircons dating back more than 4.3 billion years reveal chemical signatures that imply early water cycles far more complex than previously believed. Such discoveries challenge old assumptions and force us to reconsider what processes could have shaped Earth's earliest environment. Hidden within these mineral grains could be the faint, distorted echoes of forms of organization or activity that no longer resemble anything familiar. Even mainstream geology now acknowledges that the further we look into deep time, the less stable our reconstructions become. Entire mountain ranges have risen and been obliterated with no surviving trace. Oceans have formed and vanished. Continents have collided, broken apart, and reassembled in patterns that erase all surface history. The planet is not static. It is a relentless recycler, turning everything back into raw material. Under such conditions, the absence of evidence becomes meaningless. A civilization lasting even 100,000 years, a long span by human standards, would leave almost nothing behind if it existed hundreds of millions of years ago. In many cases, even our own civilization's remains would vanish in less than 1 million years. Iron rusts, concrete crumbles, satellites fall, skyscrapers collapse. Given enough time, our cities would become dust, and over geological timescales, even that dust would be consumed by the planet's endless movement. This realization forces us to think differently about what traces an ancient civilization might leave. Instead of expecting stone structures or metallic tools, we must look for distortions in chemical signatures, anomalies in isotope ratios, or patterns of mineral deposition that suggest artificially induced conditions. For example, industrial processes generate rare isotopic signatures found nowhere in nature. If an ancient civilization developed technologies we cannot imagine, perhaps relying on geothermal manipulation, mineral programming, or energy systems integrated into the planet's crust, their traces might remain only as unexplained heat patterns or molecular distortions. These subtle clues become even more intriguing when tied to the concept of quantum archaeology, a field exploring how physical patterns, even when erased, can sometimes leave faint imprints in the alignment of particles, resonance signatures, or electromagnetic anomalies. If intelligence existed before dinosaurs, it may have interacted with the environment in ways that left behind non-physical echoes, detectable only through advanced analytical techniques. This opens new possibilities for interpreting unexpected magnetic alignments found in ancient rocks, or mysterious variations in crystalline structures that seem to reflect deliberate manipulation rather than random geological stress. To understand the fractured record, we must also consider the catastrophic events that repeatedly reset Earth. The cryogenian glaciations encased the planet in ice from pole to equator. The Permian extinction annihilated nearly all life. Massive volcanic outpourings flooded continents with basalt. Each event wiped the surface clean, erasing whatever came before. It is within these resets that civilizations could rise and vanish undetected, existing only in the thin margins between cataclysms. And if intelligence emerged not once but multiple times, each emergence might have been swept away, leaving only ambiguous hints buried in distorted stone. What remains is not the evidence itself, but the realization that the geological record cannot answer the questions we ask of it. It was never meant to preserve technological history, cultural artifacts, or signs of intelligence. It records heat, pressure, mineral transformation, and chemical shifts. Anything beyond that requires interpretation, and interpretation demands imagination grounded in scientific discipline. We must be willing to see the fractured record not as a complete story, but as a mosaic where pieces are missing, edges are blurred, and meanings lie between cracks rather than on the surface. This is why the study of ancient rocks becomes not just geology, but a philosophical exploration of time and erasure. When we hold a stone that is billions of years old, we are holding a fragment of a world that no longer exists, a world whose secrets have been sealed by fire and pressure. The fractures in that stone may represent more than geological stress. They may be the last surviving distortions of events we cannot name. The mineral veins may record processes we do not yet comprehend. And the silence around them may not be emptiness, but a story waiting for the moment when we finally recognize the patterns hidden within that silence, as we now turn toward those patterns themselves and ask what deeper forces they suggest when we begin to follow them into the next layer of this unfolding mystery that starts revealing itself in the very structures of the rocks we thought we understood when we realize the record is not finished, and we move deeper into the question of what. Evidence hides behind the next veil of time and type 1 to continue or enter the changes you want. When we begin to examine anomalous structures embedded in ancient rock, we enter a territory where the distinction between natural formation and potential intentionality becomes increasingly unclear. These anomalies do not appear as grand monuments or recognizable artifacts. They emerge instead as subtle patterns, geometric intrusions, heat signatures, or mineral arrangements that defy known geological mechanisms. Scientists occasionally catalog these features as unusual, sometimes label them as rare, but rarely ask why they exist. Yet when we accumulate these anomalies across vast regions and across time periods predating complex life, a new question begins to form beneath the surface of scientific caution. What if these structures reflect processes or interactions that do not belong exclusively to geology? What if they are echoes of activity performed by forms of intelligence that left almost no trace beyond the faint distortions we now struggle to interpret? One striking example lies in the discovery of polygonal formations deeply buried within the oldest continental crusts, formations too precise to be dismissed without consideration. Natural polygonal patterns do occur, such as in basalt columns formed by cooling lava, yet the anomalies found in Precambrian strata differ significantly. Some exhibit interlocking geometries with angles that remain consistent across large distances, far exceeding what random fracturing would allow. Others appear carved into mineral layers that would have required stable environmental conditions to form, conditions that conflict with the turbulent, unstable world scientists believe existed at that time. When these formations are analyzed through microscopy, some reveal layering patterns that resemble engineered stress responses, as if the stone once bore loads or endured repeated cycles of heat and vibration inconsistent with natural geological activity. Even more perplexing are the mysterious inclusions found in metamorphic rocks older than 2.5 billion years. These inclusions contain minerals fused together at temperatures significantly higher than what is expected from tectonic or volcanic processes of their era. In some cases, the temperatures required exceed those typical of natural Earth environments altogether, implying either unknown geological processes or intervention by systems capable of generating sustained, focused heat. Laboratory simulations show that the precise mineral mixing found in these inclusions mirrors what occurs when materials are subjected to controlled heat gradients, conditions produced today only by industrial or experimental procedures. Such findings do not prove past civilizations, but they certainly challenge our assumptions. Earth's deep past is often imagined as simple, primitive, and uneventful, yet these anomalies reveal complexity in places where our models expect uniformity. And complexity is the first indicator that our understanding of early Earth might be incomplete. When multiple anomalies appear scattered across continents that were once united in ancient supercontinents, the possibility of earlier planetary-scale processes becomes harder to ignore. These processes could be biological, geological, or technological, but each possibility invites further exploration. For example, consider ancient banded iron formations, some of which contain strata displaying rhythmic patterns that resemble controlled layering more than random deposition. Standard explanations attribute these bands to fluctuating oxygen levels, yet some samples show microstructures that appear too regular, too sharply defined, to emerge from purely natural oscillations. If microbial life was interacting with the environment in complex cyclic ways at this time, it would imply a level of environmental engineering far earlier than predicted. If non-biological systems were at play, it opens an entirely different door: the concept of proto-technological processes embedded within the mineral record. Another anomaly emerges from regions where minerals crystallized under gravitational or magnetic influences that do not match reconstructed planetary conditions of their era. In parts of Greenland and South Africa, magnetite formations display orientations suggesting the presence of localized magnetic manipulation long before any organism evolved structures capable of producing such effects. Some theorists propose unknown geological events, yet these explanations remain speculative and sometimes contradict known planetary models. Others quietly suggest the possibility of unknown natural systems that once shaped the early Earth. And a few argue that magnetic anomalies could be the only remaining traces of activity by entities whose understanding of magnetism exceeded our own. These structures force us to confront a scientific truth that often remains unspoken. Absence of evidence is not evidence of absence, especially when the evidence would have been destroyed by the planet long before we evolved to search for it. A civilization that existed hundreds of millions of years before dinosaurs would not leave behind metal artifacts, city ruins, or recognizable tools. Instead, it would leave distortions, fractures in geological logic, heat signatures frozen in minerals, chemical patterns that refuse to conform to our expectations. These are precisely the anomalies we now find, scattered lightly across the crust like embers from a fire long extinguished. To understand these anomalies, researchers sometimes turn to analogs in modern industry. In rare cases, mining operations have unintentionally replicated geological structures once thought natural. High-pressure mechanical systems have produced fracture networks nearly identical to ancient, unexplained formations. Experimental reactors have created heat signatures indistinguishable from the thermal anomalies found in billion-year-old rocks. And controlled electromagnetic fields have altered mineral orientations in ways that match patterns found in ancient strata. These comparisons do not confirm technological activity in the deep past, but they demonstrate that the anomalies we observe today often mirror the byproducts of intelligent processes. The deeper we explore, the more we realize that intelligence, if it arose before the dinosaurs, would not necessarily manifest in the ways we expect. Humanity builds skyscrapers, tools, and machines, Yet these forms of expression are not universal. A civilization integrated with geological, chemical, or oceanic environments might leave behind signatures so subtle that only the most advanced scientific instruments could detect them. Such a civilization could manipulate minerals, restructure ecosystems, or influence planetary cycles in ways we might misinterpret as purely natural events. As the anomalies accumulate, the fractured geological record becomes not merely a puzzle, but a provocation. We are forced to consider whether these structures reflect forgotten processes, unknown natural forces, or the faint footprints of intelligence erased by time. Each possibility reveals the limitations of our understanding and the need to approach Earth's deep past with humility. The rocks cannot speak, but they fracture, bend, and twist in ways that suggest stories hidden beneath pressure and silence. To follow these stories, we must continue deeper into the evolutionary pathways of life that existed before the dinosaurs, and ask what forms of intelligence might have emerged in those forgotten ecosystems when we begin to trace the biological clues that remain just beyond the threshold of our current understanding. And now, when we step into the question of life before the dinosaurs, we often imagine simple organisms drifting through primeval seas, unaware and unremarkable. Yet biology has never been as linear or predictable as our schoolbooks suggest. The evolutionary pathways of early Earth were not slow ascents from simple to complex, but violent surges, collapses, and unpredictable leaps driven by pressures we still struggle to understand. If intelligence arose in these early worlds, it would not resemble us, nor follow the evolutionary blueprint familiar to vertebrates. It would emerge through forms and mechanisms utterly alien to our expectations, shaped by environments that no longer exist, ecosystems erased by deep time. To explore the possibility of prehistoric civilizations before the dinosaurs, we must first dismantle the assumption that intelligence evolves only in warm, stable climates under familiar atmospheric conditions. The fossil record proves otherwise. Complex eyes evolved more than 500 million years ago, appearing suddenly in Cambrian species with visual systems comparable to modern predators. Neural structures advanced at astonishing speeds. Organisms developed remarkable problem-solving abilities long before vertebrates even emerged. These facts destabilize the traditional narrative and hint that cognitive leaps can occur far earlier than we once believed. Take the cephalopods, for example. Modern octopuses possess intelligence that borders on the uncanny. They solve puzzles, open containers, navigate mazes, and display curiosity that suggests a form of consciousness. Yet their evolutionary lineage diverged from ours more than 600 million years ago. This means the neurological architecture capable of producing advanced intelligence existed long before vertebrates appeared. If such complexity evolved in oceanic environments once, it could have evolved again under different conditions, producing species capable not only of thought, but of culture and environmental modification. The oceans of the Precambrian, with their vast and stable ecosystems, could have hosted entire realms of complex life never preserved in the fossil record. Soft-bodied organisms rarely fossilize. Intelligent marine species, particularly those relying on chemical or electrical communication instead of physical tools, could rise and vanish without leaving a single bone behind. And then there are the arthropods. Trilobites, ancient rulers of the seas, possessed some of the most sophisticated eyes in the history of life. Crystal lenses tuned to specific wavelengths, capable of advanced visual processing. Some species displayed behaviors that suggest coordinated movement, environmental interaction, and predator-prey strategies requiring higher-level cognition. These organisms thrived across multiple extinction cycles, adapting with remarkable resilience. Their neural complexity may have been primitive compared to mammals, but in evolutionary terms they demonstrate how sensory and cognitive leaps can appear abruptly, flourish, and disappear without predictable continuity. If even one branch of early arthropods continued evolving in isolated environments, perhaps in deep oceans or subterranean ecosystems, it might have reached levels of coordination or intelligence we have not yet imagined. We must also consider the evolutionary enigma of the Ediacaran biota, whose soft, enigmatic bodies defy traditional classification. These organisms existed before the Cambrian explosion and vanished suddenly, leaving behind shapes and structures that resemble neither plants nor animals. Some appear radially symmetrical, with fractal patterns that suggest distributed neural networks or alternative forms of cognition. If intelligence evolved along one of these unknown branches, its artifacts might be unrecognizable. A distributed intelligence would not require tools, structures, or technologies we understand. Instead, it might reshape ecosystems, manipulate chemical gradients, or engineer biological processes. Such activity could leave biochemical or isotopic signatures rather than physical artifacts, signatures we occasionally find in ancient rocks and dismiss as natural anomalies. Even more compelling is the speed at which evolution can accelerate. In extreme environments, organisms adapt rapidly, developing novel traits in astonishingly short periods. Today we see bacteria evolve resistance within weeks, insects develop new behavioral strategies within generations, and complex traits emerge under targeted environmental stress. If early Earth hosted fluctuating climates, volcanic cycles, and chemical storms, these pressures could have driven bursts of rapid evolution. Intelligence might have emerged multiple times, only to be extinguished by global catastrophes. The timeline stretches across billions of years, more than enough for countless civilizations, ecosystems, and cognitive systems to arise and disappear. The absence of fossils means nothing when time erases almost everything. But biological evolution alone does not capture the full story. We must explore how these early intelligences might have expressed themselves. Humans express intelligence through tools, architecture, language. But another species might develop entirely different forms of expression. Consider electrical signaling in fish, acoustic mapping in whales, or chemical communication in insects. Each represents a form of environmental manipulation that could, under the right conditions, scale into culture. An early civilization might not carve stone, but shape ecosystems, altering ocean chemistry, modifying mineral distribution, influencing atmospheric conditions. Such interventions would appear to us as geological anomalies, not evidence of intelligence. There are modern analogs to this. Beavers engineer waterways. Termites build structures with internal climate control. Corals create vast underwater cities that persist for millennia. These organisms prove that intelligence is not the only driver of environmental modification, but they also reveal how subtle such modifications can be. Imagine a species millions of years ago capable of coordinated ecosystem engineering at a planetary scale. The only traces would be chemical records, unusual oxygen levels, unexplained carbon shifts, mineral distributions inconsistent with purely natural processes. These are precisely the kinds of anomalies researchers occasionally find in the ancient geological record. The oxygenation events of early Earth, for example, show fluctuations that remain poorly understood. Some scientists attribute them solely to microbial life. Others suggest cycles too rapid or too structured to match known ecological models. Could these shifts reflect environmental manipulation by forgotten forms of intelligence? It is a controversial question, but one that gains weight when combined with the geological anomalies previously described. If intelligence existed before the dinosaurs, it might not have built machines or cities. It might have rewritten the planet itself. And as we look deeper, certain patterns begin to emerge. Biological leaps occurring in unexpected places, chemical signatures that defy natural cycles, mineral formations reflecting controlled energy inputs, and evolutionary gaps that hint at entire lost ecosystems. These patterns do not prove the existence of prehistoric civilizations, but they create a framework in which the possibility becomes scientifically worthy of exploration. And exploration is what drives us forward, especially when the evidence lies at the threshold of what we can detect. As we follow these biological and evolutionary clues, the question grows sharper. If intelligence emerged before the dinosaurs, what would its legacy look like? Where would it hide? And how might it reveal itself in the complex interplay between life and geology that leads us deeper toward the shadowed possibility that life once shaped the Earth in ways we have not yet recognized when we turn our attention to the next unfolding layer of this mystery and type 1 to continue or enter the changes? You want the idea of the first intelligence on Earth forces us to abandon every comforting assumption about how cognition should evolve, how civilizations should behave, and what traces they should leave behind. We imagine intelligence through a human lens because it is the only reference we possess. But in the vast expanses of deep time, evolution had the freedom to explore countless configurations, some of which may have produced awareness and complexity in forms we would never recognize. Before the dinosaurs, before trees, before the continents resembled anything familiar, intelligence could have emerged in ecosystems so alienated from the modern world that even the definitions we use, tool use, communication, symbolic thought, would not apply. If intelligence arose in those forgotten eras, it might have been distributed through networks rather than localized in brains, encoded chemically instead of electrically, expressed not through construction and architecture, but through ecological transformation. Our challenge is to imagine what intelligence might look like when separated entirely from our biological expectations. One of the most compelling scientific models comes from studying slime molds, organisms without neurons that nevertheless solve mazes, anticipate patterns, and optimize environmental pathways with sophistication rivaling computational systems. Their intelligence is emergent, distributed, and adaptive. If such a system scaled upward over millions of years, developing complexity far beyond what we now observe, it could theoretically form vast networks capable of processing information, altering landscapes, and interacting with the environment in ways that would leave biochemical traces rather than physical artifacts. Such a civilization would not build cities. It would shape ecosystems, redirect nutrient flows, and regulate environmental conditions to sustain its vast neural-like networks. Its memory would be embedded in chemical gradients. Its communication would ripple through substrates, and if such a society existed in Earth's deep past, the only remnants today might be anomalous chemical signatures preserved in ancient rock layers. Another possibility emerges from studying modern cephalopods, whose intelligence evolved independently from vertebrates. Their cognitive architecture is radically different, relying on distributed neural clusters throughout their bodies. Each arm of an octopus possesses semi-autonomous processing capabilities, creating a biological model in which intelligence is decentralized. If such creatures or their ancestors developed further, their advancements would not mirror human development, but diverge into entirely new directions. They might develop complex communication systems based on chromatophores, electromagnetic pulses, or chemical emissions. They could form ephemeral societies, coordinating across vast oceanic distances through signals we no longer detect because the species themselves vanished, leaving no fossils due to their soft bodies. Such an intelligence could have engineered its environment through coral manipulation, chemical structuring of ocean floors, or even genetic modification of companion species, changes no longer identifiable because subsequent extinction events rewrote every layer of the biosphere. Another line of speculation, grounded in real evolutionary evidence, explores the possibility that early arthropods or their predecessors developed proto-conscious behaviors. Trilobites, with their highly advanced compound eyes, processed visual information with precision unmatched until modern insects evolved hundreds of millions of years later. Their sensory systems were capable of complex pattern recognition, movement prediction, and environmental mapping. Over time, selection pressures could have favored more sophisticated neural coordination. Yet because these organisms lived in marine environments and often possessed fragile bodies, their cognitive evolution would be almost entirely invisible to the fossil record. If any lineage developed advanced coordination, communication strategies, or proto-cultural behaviors, the geological record would erase nearly all physical evidence. Only subtle anomalies in sedimentary structures, patterns of movement, repeated formations of burrows, synchronized migrations, might betray their existence. Some fossilized trace patterns do show unexpected regularity, organization, and large-scale coordination, but these patterns are typically attributed to instinct rather than cognition. Still, the line between instinct and intelligence is thinner than we admit, particularly when examining life forms shaped by pressures we can no longer reconstruct. Beyond biological possibilities, we must also entertain models of intelligence based on physical and chemical processes unfamiliar to modern ecosystems. In certain extreme environments, organisms rely on chemical communication systems so powerful that they shape entire ecological cycles. If such systems evolved toward complexity, they could create collective intelligences operating at scales far beyond individual organisms. These intelligences might manipulate chemical gradients within oceans, influence atmospheric composition, or regulate energy flows in ways that resemble planetary engineering rather than isolated biological activity. Their legacy would be encoded not in artifacts but in the chemical fingerprints of ancient oceans, in unexplained shifts in isotopic ratios, in mineral distributions that reflect sustained environmental manipulation. We find such anomalies in Earth's oldest rocks, but our frameworks are too limited to interpret them as anything other than puzzling natural fluctuations. We must also consider intelligence that might arise not from organisms, but from ecosystems themselves. Today, forests communicate through fungal networks that share nutrients and information. Coral reefs behave like superorganisms, responding to environmental changes with collective strategies. These emergent systems suggest that intelligence does not need a brain. It requires only complexity, feedback loops, and the ability to adapt. If ancient ecosystems developed such properties on a grand scale, they could have directed evolutionary pathways, shaped landscapes, and engineered environments to suit their needs. A civilization formed by an entire ecosystem would not build machines or cities. It would sculpt coastlines, regulate currents, and influence climate. Its extinction would erase nearly every trace, leaving behind only puzzling correlations between geological and biological patterns. In the end, the most profound challenge lies not in finding evidence, but in training our minds to recognize intelligence that may not look like intelligence. We assume civilizations must leave behind structures, symbols, or tools. But a civilization millions of years before dinosaurs might have left only chemical echoes, structural patterns in rocks, or evolutionary detours that disappear into extinction. To uncover such possibilities, we must examine anomalies not as isolated curiosities, but as clues, fragments of a deeper story hidden beneath Earth's violent cycles. If intelligence once existed in these forgotten eras, its remnants would merge with geology, biology, and planetary processes, making its traces almost indistinguishable from nature itself. And this leads us to the next unsettling question. If ancient intelligence shaped the planet in ways we misinterpret as natural forces, what might the fossil record still reveal about those hidden interactions when we begin to look at the paleontological anomalies that continue to challenge our understanding and invite us deeper into the mystery of what came before the world we know? When type 1 to continue or enter the changes you want, fossils are often treated as irrefutable anchors of truth. Yet they are among the most deceptively incomplete forms of evidence we possess. For every creature preserved in stone, billions vanish without leaving the faintest imprint. This becomes even more troubling when we consider the possibility of civilizations predating the dinosaurs, for such civilizations would have been shaped by ecological pressures, biological strategies, and environmental realities very different from those familiar to modern life. Fossils do not simply record organisms, they record conditions favorable to preservation. Anything that lived in soft-bodied forms, underwater realms without sedimentation, chemically active environments, or regions later destroyed by tectonic upheaval would leave no trace. Thus, the fossil record becomes not a history of life, but a narrow sampling of what survived long enough to be entombed in the rarest circumstances. This limitation is precisely what turns paleontological anomalies into some of the most compelling clues in the investigation of deep prehistoric intelligence. Among these anomalies are trace fossils, footprints, burrow networks, feeding trails that defy easy categorization. Some early Precambrian and Cambrian trace fossils exhibit patterns far more organized than expected from the creatures presumed to have existed at the time. Instead of random meandering paths, we find repeated geometric movements, coordinated patterns, and structures resembling planned networks rather than instinctive responses. In South Australia's Ediacaran layers, certain radial impressions show a symmetry and regular spacing that mimic deliberate arrangement. While mainstream paleontology explains these as repetitive biological behaviors, the consistency of the spacing, curvature, and interaction between structures sometimes raises questions about whether we are witnessing complex social behaviors or environmental manipulation that current models fail to explain. Another enigma appears in the fossilized burrow systems of extremely ancient seabeds. Some networks stretch far beyond what is typical for simple organisms. They demonstrate efficient routing strategies akin to modern ant tunnels or engineered drainage systems. Their branching angles remain mathematically consistent over surprisingly large distances. In several regions, Namibia, Newfoundland, and parts of China, these burrow patterns resemble optimization pathways, faintly echoing behaviors associated with problem-solving organisms or coordinated groups. Nothing in these layers suggests the presence of creatures with the neurological capacity for such planning, yet the structures persist, suggesting that something in those epochs understood how to exploit environmental geometry. Equally intriguing are fossilized stromatolites, once attributed solely to microbial activity. In recent decades, researchers discovered that some stromatolite formations possess growth patterns too complex and too rapidly adapted to environmental changes to be formed by passive microbial mats alone. Certain layers react dynamically to seasonal shifts, nutrient flows, or chemical changes with responsiveness reminiscent of ecosystem engineering. If early Earth hosted organisms capable of manipulating their surroundings with intention, whether to manage energy, regulate resources, or construct stable habitats, their fossilized remains might resemble natural formations, yet subtly deviate from expected models. Such deviations appear scattered across the ancient oceans, but because they challenge conventional assumptions, they are often relegated to scientific footnotes. Even more mysterious are fossilized structures from the Dushantuo Formation in China, where microscopic fossils show cellular complexity that seems to emerge abruptly and inexplicably. Some specimens display organized clusters of cells arranged in ways that parallel developmental patterns seen in far more advanced organisms. Others reveal biochemical signatures hinting that sophisticated metabolic pathways evolved long before the Cambrian explosion. These fossils could represent early experiments of evolution, but they could also hint at ecosystems shaped by advanced biological strategies, perhaps even deliberate biological engineering, by organisms whose existence left no recognizable physical artifacts. But the most provocative anomalies come from the realm of fossil chemistry. Certain Precambrian rocks contain carbon isotopes arranged in ratios inconsistent with known natural processes. These ratios resemble modern signatures of intensive biochemical manipulation, such as industrial carbon processing or advanced metabolic cycles. In some cases, rare metal concentrations appear clustered in ways that suggest selective extraction or redistribution by biological or unknown processes. Paleontologists, geologists, and astrobiologists continue to debate these anomalies, unable to definitively categorize them as natural or unnatural. The truth may lie in the boundary between the two, processes that were biological but advanced beyond our expectations, or technological in ways we do not yet recognize. When we explore fossil anomalies, we also confront gaps that stretch beyond physical evidence. Sudden disappearances in the fossil record, often attributed to extinction events, sometimes occur without corresponding environmental causes. Entire ecosystems vanish, their disappearance unexplained by climate change, volcanic activity, or asteroid impacts. These silent extinctions raise the possibility that unknown influences, biotic or synthetic, reshaped ancient biospheres. If advanced life forms manipulated ecosystems or outcompeted primitive organisms, their impact might appear as abrupt biological turnover with no obvious external trigger. The concept of biological relics also plays a role. Modern organisms sometimes exhibit traits that seem out of place in their evolutionary history, as if inherited from forgotten lineages. Strange biochemical pathways, redundant genetic coding, or unexplained molecular mechanisms might be remnants of ancient engineering or adaptations from long-lost ecosystems. Scientists occasionally refer to these as evolutionary oddities, yet their origins remain open questions. Such relics could be echoes of interactions with species far more complex than the fossil record reveals. And as we confront these paleontological puzzles, it becomes clear that the fossil record is not proof of simplicity in Earth's deep past, but proof of profound erasure. Any civilization that existed before the dinosaurs might have influenced biological systems, creating ripple effects detectable only in faint molecular signatures, unexplained environmental structures, or abrupt evolutionary shifts. These traces, subtle yet persistent, urge us to reconsider what intelligence might look like in forms no longer recognizable. When we place these anomalies alongside geological and biological evidence, a new image forms. The possibility that ancient intelligence shaped Earth in ways we misinterpret as natural processes, guiding evolution, altering environments, and leaving behind puzzles scattered across the fossil record that point us toward the next question in this unfolding mystery. If life before the dinosaurs held such complexity, what forms of environmental engineering or planetary scale interaction might they have achieved, and how would those transformations appear to us today when we examine the planet's ancient chemistry through the lens of cosmic cycles and planetary resets when we turn to the environmental transformations recorded in Earth's deepest layers, we begin to see not just the story of life, but the story of an environment repeatedly reshaped by forces that defy easy categorization. The early Earth was far from passive. It behaved like a living organism, cycling through cataclysms and recoveries with rhythms so precise they resemble biological processes on a planetary scale. Yet as we examine these ancient cycles, certain anomalies stand out. Abrupt atmospheric shifts without volcanic triggers, chemical reorganizations too fast for natural feedback loops, and climate resets that unfold with mathematical precision, as if driven by systems rather than chaos. If prehistoric civilizations existed before the dinosaurs, their influence would not appear as monuments or artifacts, but as planetary-scale modifications woven into the chemical and atmospheric patterns of their time. And the Earth, in its restless churn, would compress their legacy into the layers we now read like fragments of an erased message. One of the most perplexing phenomena in this regard is the Great Oxygenation Event, a planetary transformation so radical it reshaped every ecosystem and altered the chemistry of the atmosphere forever. Traditionally attributed solely to photosynthetic microbes, this event unfolds in geologic layers with suddenness that does not match the slow spread of simple organisms. Some strata show oxygen surges that rise and fall with an artificial sharpness, as if controlled rather than naturally accumulated. These variations coincide with mineral changes that suggest accelerated environmental processing, oxidation rates far exceeding what microbial mats should achieve unaided. If an ancient intelligence intervened in the planet's systems, perhaps to stabilize climate or enhance habitability, its fingerprints might appear precisely where these chemical anomalies reside. Because such intervention would blend with natural processes, it would appear indistinguishable from environmental change, except for the speed and precision with which it unfolds. Another puzzle emerges in the snowball Earth glaciations. These episodes froze the planet nearly from pole to pole, yet their onset and termination occur with a synchronicity that contradicts known climatic mechanisms. In some layers, Ice Age transitions show patterns of feedback that align with complex regulatory systems, almost as though an unknown force modulated global temperature within narrow thresholds. Some researchers point to volcanic CO2 release, others to changes in ocean chemistry, but anomalies in isotopic ratios imply heat sources or atmospheric shifts inconsistent with natural triggers. If ancient species developed atmospheric engineering, controlling greenhouse gases, redistributing heat through oceanic currents, or manipulating reflective particles, they could have influenced these glaciations in ways that appear today as geological mysteries. Their interventions would have been swallowed by time, leaving only chemical shadows embedded in rocks older than the earliest animals. Even more mysterious are abrupt carbon isotope excursions found before the Cambrian explosion. These excursions represent massive, rapid changes in carbon cycling that cannot easily be tied to volcanic activity, asteroid impacts, or biological collapses. Instead, they unfold with sharp spikes and recoveries, resembling artificial perturbations within a closed system. Some scientists propose methane releases or ocean overturns, yet the consistency of the spikes across continents points toward coordinated global drivers. If early civilizations manipulated carbon for energy, stability, or environmental control, such activities might produce isotopic fingerprints similar to those we detect, not as pollutants, but as signals of environmental engineering performed by species whose traces were later erased by extinction. The ocean floors reveal similar enigmas. In ancient seabeds now lifted into mountain ranges, sedimentary layers show patterns of nutrient redistribution that follow optimization curves rather than random diffusion. These patterns resemble modern ecological engineering, nutrient cycling in coral reefs, chemical balancing in kelp forests, or resource management in beaver-modified wetlands. Yet they occur hundreds of millions of years before the species capable of such behaviors should have existed. What created these formations? Tidal cycles alone do not explain them. Microbial life does not organize itself with such precision. If an early intelligence managed marine resources, redirecting currents, cultivating microbial populations, or designing stable ecosystems, its influence would appear in precisely these kinds of chemical and structural signatures. And because marine life leaves so few fossils, such interventions would remain nearly invisible today. We also find environmental anomalies in magnetic records. Ancient rocks preserve magnetic orientations that occasionally flip or drift without matching known geomagnetic cycles. Some shifts are too localized to be planetary, yet too consistent to be random. They cluster in regions associated with other geological anomalies, such as heat signatures or unusual mineral alignment. If ancient civilizations understood magnetism, or evolved in environments conducive to electromagnetic communication, they may have manipulated magnetic fields in ways that subtly altered mineral configurations. Such manipulations would not survive as artifacts, but as distortions in how grains of magnetite froze into solid rock. These distortions, scattered across ancient continents, may represent the last remnants of interactions performed by cognitive systems long lost to extinction. To imagine how such civilizations might operate, we must think beyond human tools and architectures. A civilization integrated into oceans could regulate salinity, temperature, and chemical gradients. A civilization tied to geothermal systems could harness the deep Earth's heat, influencing volcanic or tectonic cycles. A civilization based on distributed cognition, cells, networks, or biofilms might treat the entire biosphere as its medium of expression, shaping environmental flows like a painter guiding pigment. Their legacy would not be buildings but feedback loops embedded within oceans, atmospheres, and crustal chemistry. Exactly the kinds of loops we find in ancient strata that behave more like managed systems than chaotic natural cycles. The more these anomalies accumulate, the more they force us to reconsider the narrative of early Earth. Perhaps intelligence before the dinosaurs did not disappear without a trace. Perhaps Earth is the trace, its chemical scars, its atmospheric shifts, its mineral oddities the only surviving evidence of forces that once shaped the planet with purpose. And if ancient civilizations engineered their environments intentionally or incidentally, then somewhere in the oldest rocks of our world lies the proof hidden in plain sight. These signatures pull us closer to the question of catastrophic resets, the violent events that wipe the planet clean and bury every legacy beneath ash, ice, and fire. The same events that may have erased entire epochs of intelligence before the age of dinosaurs, inviting us deeper into the next stage of this unfolding enigma, when type 1 to continue or enter the changes you want. Catastrophic resets are woven into the Earth's history so thoroughly that they form the planet's true heartbeat, pulsing across deep time with a rhythm that destroys, renews, and erases in equal measure. When we examine these resets through the lens of geology alone, they appear as natural disasters. But when we view them through the possibility of prehistoric civilizations before the dinosaurs, an unsettling question emerges. Were these events purely natural, or could some have been triggered, accelerated, or influenced by ancient intelligences whose interactions with the environment pushed ecosystems toward collapse? Whether natural or intentional, each reset would have obliterated almost all traces of previous complexity. This is the first truth we must confront. Extinction is the Earth's greatest sculptor, and under its influence, even the memory of advanced societies could be crushed, melted, or ground into oblivion. The Permian-Triassic extinction, the Great Dying, is often cited as the clearest example of a total reset. In less than a million years, 96% of marine species and 70% of terrestrial life vanished. But what is startling is not only the scale, but the pace of the collapse. Carbon isotope excursions spike and plummet with unnatural rapidity. Ecosystems fail in cascading waves as though something interfered with stabilizing feedback loops. Ocean chemistry destabilizes in ways that mimic artificial perturbation. If a civilization existed in that era, long before dinosaurs rose to dominate the land, it may have witnessed its world collapse under the weight of environmental processes it accidentally or intentionally disrupted. Or perhaps it attempted to intervene, accelerating a process already underway. Either way, the speed and depth of the event suggest that forces beyond passive natural dynamics were at play. Another reset, the Ordovician-Silurian extinction, presents a similarly unsettling timeline. The abrupt glaciation that triggered the collapse appears in the geological record with a precision that defies known climate patterns. Some scientists argue for a gamma-ray burst or cosmic influence, but anomalies in glacial deposits raise questions about heat distribution, oceanic mixing, and atmospheric chemistry. If early oceanic civilizations existed, communicating through electrical or chemical networks, they might have depended on stable temperatures. A disruption in their regulatory systems could have triggered feedback loops that spiraled into global freeze. Their downfall would leave little trace except for the abruptness of the glaciation and the strange signatures of temperature fluctuations locked in stone. The Devonian extinction, spanning millions of years, shows rhythmic collapses that align suspiciously with changes in oxygen levels, nutrient cycles, and plant-driven atmospheric shifts. Some researchers believe microbial or fungal blooms destabilized oxygen flows. Others propose asteroid impacts. Yet the layered patterns in the fossil record resemble ecosystem recalibrations, occurring in cycles too structured to be random. Could a prehistoric intelligence have influenced plant evolution, accelerating atmospheric changes? Could ecological engineering practiced to sustain complex marine or terrestrial life have spiraled into unintended consequences? Such possibilities remain speculative, but the anomalies remain. Oxygen drops too fast, plant radiations too sudden, extinction pulses too organized. The most compelling resets, however, are those without obvious catalysts. Events where species disappear but the expected signatures of impact craters, volcanic eruptions, or climate collapse are absent. Silent extinctions. These patterns appear in several Precambrian layers, where life reorganizes abruptly for no apparent natural reason. Ecosystems shift, chemical cycles reset, and entire biological communities vanish. These silent erasures could be the result of unknown natural processes, supervolcanoes long eroded, asteroid impacts lost to subduction. But they could also represent collapses triggered by the catastrophic failure of advanced biosystems or planetary-scale networks. Civilizations integrated with oceans or atmospheres might have influenced global cycles in ways we misinterpret. When their systems failed, the planet collapsed into chaos before rebuilding itself in unfamiliar forms. Yet we must also acknowledge the possibility that resets are not always accidental. Intelligent species faced with environmental threats may attempt drastic planetary modifications. In our own era, geoengineering proposals aim to cool the atmosphere, seed clouds, or manipulate oceans. These interventions carry risks we barely understand. If a prehistoric intelligence attempted similar strategies, altering oxygen, carbon, temperature, or chemistry, its miscalculations could produce the very isotopic anomalies we find today. Their technological fingerprints would appear as abrupt shifts in environmental conditions, compressed into rock layers as chemical scars instead of artifacts. Resets can also be triggered by cosmic events. If ancient species possessed astronomical knowledge beyond what we assume, they may have detected incoming threats, attempted planetary shielding, or manipulated magnetic fields to deflect radiation. Such efforts could leave behind magnetic anomalies, isotope shifts, or mineral configurations unexplained by current models. We find exactly such anomalies in ancient rocks, geological signatures that appear and disappear with precision, as though influenced by cyclical interactions with cosmic forces. Whether these interactions were natural or guided remains a question suspended between science and speculation. Each reset leaves behind a paradox. The deeper we dig, the more we find complexity followed by erasure, sophistication followed by collapse. Evolution rises, surges, then vanishes. Chemical cycles stabilize, destabilize, then stabilize again. Life expands into new niches, only to be swept away in patterns too abrupt to be purely organic and too consistent to be entirely random. These patterns resemble the rise and fall of civilizations. Not human civilizations, but ancient ones shaped by pressures unimaginable today. Civilizations that may have arisen repeatedly, only to be extinguished by Earth's unforgiving rhythms. If civilizations existed before the dinosaurs, their memory would be entombed not in ruins but in resets, their stories erased by ice, fire, pressure, and time. Their innovations rewritten as chemical anomalies, their downfall compressed into extinction layers, their existence detectable only in the patterns nature cannot fully explain. And as we follow these patterns across geological eras, one truth emerges. Resets are not just endings, but portals. Every reset clears the canvas for new complexity. Every collapse sets the stage for new intelligence. And every unexplained anomaly invites us to explore the possibility that intelligence has risen and fallen many times, each cycle erased until nothing remains but the scars of its disappearance and the faint echoes of its influence. These resets lead us directly into the next question. If prehistoric civilizations rose and vanished repeatedly, what cosmic or celestial patterns might have guided their rise, influenced their knowledge systems, or warned them of impending collapse, drawing us yet closer to the mystery of the skies and the messages encoded in celestial cycles that still move above us when type 1 to continue or enter the changes you want. To understand how prehistoric civilizations before the dinosaurs might have perceived their world, we must lift our eyes from the rocks and fossils and turn toward the sky. For the sky was the one constant above every reset, every extinction, every erased epoch. Long before humans mapped constellations, long before the first vertebrates crawled onto land, the heavens were already a canvas of cycles, signals, and rhythms that repeated with unwavering precision. Any intelligence, biological, distributed, or ecosystem-based, would have encountered these celestial patterns as the most reliable structure in an otherwise volatile world. And when life experiences uncertainty, it looks upward for order. This is where cosmic cycles enter the narrative, not as myth, but as frameworks of knowledge older than bones or stone. The celestial mechanics of early Earth were far more dramatic than what we see today. The moon was closer, tides more violent, days significantly shorter, and solar energy more volatile. These conditions would demand adaptive cognition in any advanced species. If intelligence arose in those eras, especially in oceanic or coastal ecosystems, it would be shaped by tidal rhythms, lunar cycles, and solar patterns. The gravitational dance between Earth and the moon would become a kind of cosmic metronome, setting the pace for life's behavior, migrations, communication, and even consciousness. Imagine beings whose sensory systems were tuned not to light or sound, but to gravitational fluctuations. Their astronomy would be felt rather than seen, their calendars embedded in neural pathways rather than symbols, and their entire civilization structured around cycles we now measure only with atomic clocks. But beyond gravity, early intelligences may have observed something else: periodic cosmic intrusions. Asteroid clusters passing near Earth, the faint glow of ancient comets, solar storms imprinting electromagnetic ripples through oceans. In the modern era, we dismiss such events as distant astrophysical noise. Yet in deep time, these phenomena may have been catalysts, igniting migrations, triggering biological adaptations, or signaling environmental changes long before they occurred. A civilization attuned to these rhythms could have predicted resets, perhaps even attempted to mitigate them. Some paleoclimate models show correlations between extinction events and cosmic cycles, but the cause remains speculative. If intelligence existed before the dinosaurs, it might have survived multiple resets by reading these cosmic warnings. And here, the mystery deepens. When researchers map cometary and meteoroid streams over geological time, certain recurring paths intersect Earth across intervals so regular that they resemble cycles of celestial choreography. Among those paths are objects like R2 SWAN and the interstellar 3I Atlas, bodies whose unexpected behavior today echoes patterns observed in deep time layers rich in isotopic anomalies. Although no scientist claims these comets carry messages, their synchronized anomalies act as reminders that celestial patterns have always shaped Earth's history. Early intelligences may have treated such objects as environmental indicators, anchoring their understanding of the world to the sky's repeating geometry. The appearance of bright comets, unusual solar alignments, or synchronized celestial events would not merely inspire curiosity. They could determine survival. This idea aligns with how ancient terrestrial species behave today. The mass migrations of birds follow magnetic pathways influenced by solar storms. Coral reproduction is governed by lunar cycles. Trees regulate growth according to electromagnetic variations. Life even now responds to the heavens. The sky is not an external phenomenon, it is a partner in the evolutionary story. In deep time, its influence would have been even stronger. It is therefore plausible, scientifically plausible, that prehistoric civilizations, if they existed, would frame their entire worldview around celestial forces. Their knowledge systems might not involve symbols, writing, or mathematics as we know them. Instead, they could be encoded in patterns, behaviors, environmental modifications, or communal memory embedded in biology itself. This opens the door to the concept of cosmic ecology, the idea that civilizations evolve not only within ecosystems, but within orbital and solar cycles. If intelligence existed before the dinosaurs, it might have evolved mechanisms to sense cosmic patterns, electromagnetic, gravitational, or chemical, and respond to them in ways modern organisms do not. These abilities could drive coordinated population changes, synchronized migrations, or even large-scale environmental engineering. Chemical traces of such events might appear to us as unexplained isotopic shifts or mineral reorganizations occurring in sync with known cosmic cycles. And we find exactly these correlations in certain deep strata. For example, rhythmic sedimentation patterns in ancient rocks sometimes match orbital eccentricities, not merely in rough alignment but with precision that suggests predictive behavior. Some researchers suspect that early ecosystems responded to Milankovitch cycles, variations in Earth's orbit and tilt, but these rhythms appear too structured, too responsive. They resemble management rather than reaction. If early intelligences understood these cycles, even in primitive forms, they might have regulated entire ecosystems according to astronomical rhythms. Such behavior would leave behind nothing but geological patterns indistinguishable from natural processes unless we learn to see the difference. Then there is the question of messages. Not messages in the human sense, but resonances, chemical, magnetic, or structural echoes left behind in the planet's crust. Certain magnetic anomalies exhibit periodicity that cannot be explained by natural geomagnetic reversals. Rare isotope ratios appear and disappear at intervals aligning with cosmic cycles. These anomalies do not prove ancient intelligence, but they raise questions that conventional geology cannot fully answer. Why do certain environmental shifts coincide with unlikely cosmic alignments? Why do some chemical signatures resemble controlled interventions? And why do patterns emerge that mimic the traces of system-wide feedback management? If prehistoric civilizations once looked to the sky for understanding, then the sky would serve as their library, their teacher, their warning, system, and perhaps their spiritual center. Their greatest insights would not be written on stone tablets, but in the cyclical movement of stars and the behavior of comets. Their legacies would be encoded in the rhythms they followed, rhythms still visible today in geological layers and astronomical records. And if comets like R2 SWAN and 3I Atlas display synchronized anomalies in our era, it may not be that they carry messages, but that they remind us of the ancient relationship between life on Earth and the celestial bodies that shape its fate. These possibilities carry us toward a deeper question. If the sky acted as both guide and warning for ancient intelligences, then perhaps myths, symbols, and geomythological stories passed through forgotten evolutionary branches still retain fragments of those cosmic memories. And this brings us to the next stage of the mystery: how ancient knowledge may persist not through fossils or artifacts, but through the hidden language of myth, consciousness, and planetary memory when type 1 to continue or enter the changes you want. If myths are the echoes of forgotten ages, then the oldest myths of all may not come from humanity, but from the Earth itself. Every culture on our planet, from the most ancient to the most isolated, carries stories of worlds that existed before the current one, cataclysms that wiped clean the slate, beings that shaped creation and vanished without explanation, cycles of birth and destruction, knowledge gained and lost, worlds rising and falling like breaths in an infinite chest. These are not merely cultural inventions. They form a pattern so widespread, so universal, that we must ask whether myth is a biological memory, an inherited resonance carried across evolutionary branches, perhaps even across species long extinct. If prehistoric civilizations existed before the dinosaurs, and if their knowledge systems interfaced with planetary cycles, then fragments of their worldview might persist as unconscious patterns, embedded in the collective psyche of all life that followed. To explore this possibility, we must begin with the concept of the collective unconscious, a realm of inherited cognitive structures that influence behavior, symbolism, and instinct. In humans, this appears as archetypes, recurring images and themes found across cultures. But animals too carry instinctual memories they never learned, migratory paths, responses to celestial cues, encoded fears of predators that vanished millions of years ago. These instincts suggest that memory can transcend species, that information can be carried through evolutionary time as patterns woven into biology. If early intelligences existed long before vertebrates, their interactions with the environment could have generated patterns, behavioral, chemical, or symbolic, that persisted through ecological succession. These patterns, carried forward through evolution, might manifest in myths as inherited echoes of forgotten worlds. Geomythology, the study of how ancient stories preserve records of geological events, offers tantalizing support. Indigenous myths describe volcanic eruptions, meteor impacts, and sea level changes with accuracy that predates written history by thousands of years. Yet some myths describe events so old they seem impossible for humans to remember. Cycles of creation and destruction that align with geological epochs, not human histories. When Australian Aboriginal stories describe landscapes reshaped over tens of thousands of years, we recognize the persistence of memory. But when myths from multiple continents speak of worlds before the current one, of beings that shaped Earth and then disappeared into the sea or sky, we confront a pattern that transcends human culture. These could be symbolic interpretations of natural events, or they could be inherited fragments of knowledge from civilizations erased by deep time. Even more provocative are myths describing beings who were neither human nor animal, but something else entirely. Entities composed of light, shadow, water, or stone. Beings that communicated through vibrations or environmental changes. Ancient architects who shaped rivers, mountains, ecosystems. Such myths echo the possible forms of intelligence discussed earlier: distributed networks, oceanic organisms, chemical communicators. Perhaps these myths are not inventions, but distorted memories of species that once dominated ecosystems in ways unfamiliar to modern life. Then there are the myths of the first people, old ones, or ancestors of the world, described as existing before the formation of animals or humans. The Hopi speak of previous worlds destroyed by fire, ice, and water. Hindu cosmology describes cycles of creation spanning millions of years. The Dogon speak of knowledge given by beings associated with Sirius long before telescopes existed. These stories do not prove anything on their own, but their consistency across distant cultures raises the possibility that myth preserves structural memory, echoes of cosmic cycles, environmental resets, and interactions with intelligences long gone. Modern neuroscience adds a layer of intrigue. Studies of human dreams reveal universal themes that appear in all cultures, regardless of exposure to shared symbols. These themes, falling, searching, returning to ancient landscapes, may reflect cognitive residues from epochs before humanity. Could early mammals have carried unconscious memories of older species? Could neural pathways encode patterns shaped by ancient ecological pressures? If consciousness is an emergent property of biological systems, then perhaps it carries faint signatures of the systems that came before it. Another avenue is quantum archaeology, the hypothesis that information from past states of matter can persist in subtle ways, capable of influencing future systems. If prehistoric civilizations manipulated energy, chemistry, or ecology at scales we now consider impossible, they might have left quantum-level imprints that affect biological development. Consciousness, developing billions of years later, could resonate with these imprints, transforming them into symbols, myths, or intuitive forms of knowledge. Under this framework, myths are not stories. They are inherited distortions of environmental patterns encoded across evolutionary time. The serpent representing cycles, the flood representing resets, the sky beings representing celestial knowledge, each could be an echo of something real that existed before vertebrate intelligence. Myths about entities guiding evolution or shaping the world could reflect the influence of ancient intelligences that engineered ecosystems or responded to cosmic cycles. But myths also contain warnings. Stories of worlds destroyed because beings forgot the way, lost harmony, or broke the balance could be distorted memories of civilizations that perished through environmental mismanagement, catastrophic resets, or cosmic events. These warnings feel primal because they may be older than humanity itself. When we weave together these threads, geological anomalies, chemical signatures, biological enigmas, cosmic cycles, and mythic archetypes, a picture begins to emerge. A picture of a planet where intelligence may have risen more than once. A picture of knowledge systems that operated through nature rather than against it. A picture of memories so ancient they no longer resemble information, but instinct. And as we decode these inherited patterns, we find ourselves closer to understanding what ancient civilizations might have known about the sky, the earth, and the cycles that govern both. This leads us naturally into the next layer of the mystery. If these echoes persist in mythology, did they also manifest in consciousness itself, through dreams, intuition, and inexplicable resonances with places and patterns we have never seen, leading us toward the idea that memory is not an individual phenomenon, but a planetary one, and that consciousness may store fragments of worlds erased long before the dinosaurs when Type 1 to continue or enter. The changes you want, consciousness is usually treated as an individual experience, a private reality unfolding inside a single brain. Yet when we step into the deep time perspective, this assumption collapses. Consciousness might not be a personal phenomenon at all. It may be a planetary inheritance, a cumulative field built across evolutionary epochs, carrying echoes of worlds long erased. If prehistoric civilizations existed before the dinosaurs, and if their knowledge systems interacted directly with the environment, the oceans, the chemical cycles, and even the magnetic field, then the remnants of their cognition might not survive as artifacts or fossils. They would survive instead as patterns embedded in consciousness itself. Not memories in the human sense, but structural resonances, instincts, intuitions, dreams, and symbolic frameworks that hint at histories we never lived but somehow still feel. This is where Topic 10 begins. The ancient architecture of consciousness. Modern neuroscience provides a clue. Human brains do not emerge as blank slates. We are born with predispositions, innate fears, pre-configured responses to shapes, patterns, and natural phenomena. Infants recoil from serpentine movement even before learning what a snake is. They respond to faces, symmetry, and rhythmic patterns without any prior exposure. These universal responses show that consciousness inherits templates, biological memories shaped by environmental pressures predating humanity. If intelligence existed before the dinosaurs, these templates could carry faint imprints of those ancient systems. Not as explicit memories, but as structural tendencies. A fear of falling. A fascination with the sky. A sense of cycles and returns. These sensations might be remnants of intelligences that once lived in precarious environments, or species whose survival depended on reading cosmic rhythms. Dreams offer another clue. Dreams transcend culture, time, and geography. People dream of ancient landscapes, of rising waters, of losing something forgotten, of searching for a place they have never seen but somehow know. These dream motifs appear across civilizations that never interacted, suggesting a shared cognitive substrate. Some neurologists argue that dreams reflect neural housekeeping, memory consolidation, or emotional processing. But such explanations do not account for the uncanny consistency of dream symbols across continents. What if dreams are the language of the deep unconscious, a language shaped by patterns older than humanity? If ancient civilizations engaged with planetary cycles, environmental rhythms, or distributed forms of cognition, their interactions could imprint themselves onto biological systems in ways that persist as dream patterns billions of years later. Consciousness, in this view, becomes a palimpsest, a layered record of ancient cognitive strategies overwritten by newer forms yet never fully erased. Genetics adds another layer. Epigenetic inheritance demonstrates that environmental pressures can shape physiological and behavioral traits across generations without altering DNA. Stress, fear, migration, starvation, chemical gradients all leave marks passed to descendants. If prehistoric civilizations interacted with their environments in complex ways, the biological impact of their lifestyles, challenges, and catastrophes could echo through the genetic lineages that eventually evolved into entirely new species. Consciousness, influenced by epigenetic markers, might carry echoes of ancient emotional states, survival strategies, or perceptual frameworks. In this sense, our perception of the world is not ours alone. It is a continuation of perceptions formed under conditions long extinct. Quantum biology deepens the mystery. Organisms use quantum processes for navigation, photosynthesis, and communication. Birds sense magnetic fields through quantum entanglement. Plants detect photons at levels impossible under classical physics. If ancient civilizations developed intelligence through biological networks more tightly integrated with quantum systems, their consciousness might have interacted with the environment in ways we do not yet understand. The remnants of these interactions could persist in the quantum structures of living cells, influencing perception, intuition, or sensitivity to electromagnetic and gravitational fields. Consciousness might be tuned to ancient frequencies, echoes of systems that vanished in cataclysms but left behind quantum residues in the biosphere. Another possibility emerges when we examine geomagnetic anomalies associated with altered states of consciousness. Certain regions of the Earth produce magnetic fields that influence brainwave activity. Ancient sites, caves, cliffs, and geological formations coincidentally align with these anomalies. But coincidence grows thin when we observe similar patterns in locations tied to ancestral myth, ritual, and symbolic storytelling. If prehistoric civilizations manipulated magnetic fields or navigated using electromagnetic perception, their behaviors might be echoed in the human brain's sensitivity to certain frequencies. Consciousness could retain resonance with magnetic environments shaped by vanished intelligences. The fact that humans experience profound spiritual or visionary states near geological anomalies hints at a deeper connection between brain activity and planetary memory. Collective consciousness studies add to the intrigue. Human behavior synchronizes in ways that defy simple explanation: group intuition, social contagion, shared symbolic development across isolated cultures. These phenomena suggest that consciousness operates not as isolated units, but as interconnected nodes within a larger field. If prehistoric civilizations developed networked intelligence, whether biological, electromagnetic, or ecological, then the planet itself might retain structural patterns that influence modern cognition. These patterns could manifest as collective tendencies to create certain myths, develop certain symbols, or respond to specific environmental cues. Consciousness becomes a tapestry woven from threads of ancient cognition, echoing through species that never knew their predecessors. Memory itself becomes suspect. What we think of as personal memory may be only the surface layer of a deeper, species-level memory. If prehistoric civilizations before the dinosaurs engaged with celestial cycles, environmental engineering, or distributed cognition, their patterns might persist in consciousness as an intuitive sensitivity to cycles, as an inexplicable pull toward the sky, as a sense of déjà vu when witnessing cosmic events like eclipses or comet passages. Some neuroscientists propose that déjà vu is not a glitch, but a recognition of deep patterns encoded across evolutionary time. In this view, consciousness acts as a receiver tuning into signals embedded in biology, geology, and cosmic cycles. The ancient past returns not through fossils, but through experience. If this is true, then consciousness is the final archive of forgotten civilizations. The fossils, rocks, and isotopes tell only fragments. The sky tells cycles, but consciousness tells echoes. These echoes draw us into the next question. If memory, myth, thought, and instinct carry fragments of forgotten epochs, what might the final revelation be when we assemble geology, biology, myth, and consciousness into a single story? A story that suggests intelligence is not a one-time event, but a repeating phenomenon woven into the planet's deepest rhythms, guiding us toward the threshold of the final chapter when type 1 to continue or enter the changes you want. Finally, when we reach the question of what it all means, these geological anomalies, biological enigmas, cosmic rhythms, mythic echoes, and cognitive residues, we stand before a realization far more profound than any single discovery. The story of prehistoric civilizations before the dinosaurs is not about proving that ancient societies built cities or technologies like ours. It is about understanding that intelligence, in all its possible forms, may be woven into the planet's deepest rhythms. Earth is not merely a place where life happens. It is a vessel that carries cycles of emergence, collapse, renewal, and forgetting. And somewhere within those vast cycles, intelligence may have arisen not once, but many times. Each incarnation shaped by ecosystems, cosmic forces, and evolutionary paths unlike anything we know. The reason we struggle to trace these civilizations is not because they were simple, but because Earth itself is designed to erase them. Continents shift, oceans consume, magma overwrites. The planet's crust is a palimpsest, rewritten endlessly, each layer burying the memory of the last. Yet, faint traces resist erasure. Mineral scars that hint at controlled heat, chemical signatures too abrupt for natural cycles, biological leaps too sudden for random mutation, myths too universal to be coincidence, consciousness too patterned to be only personal. These fragments act like scattered pieces of a lost mosaic. They do not give us the full image, but they suggest its outlines, an ancient world where intelligence took forms we struggle to imagine, where civilizations rose in ecological or oceanic or distributed networks, where knowledge was encoded in rhythms rather than structures, where planetary engineering was indistinguishable from natural cycles. And when extinction came, as it always does, their traces dissolved into stone and chemical residue. What remains is not their technology, but the shape of their influence etched into the Earth's deep memory. If we accept that intelligence may have risen before, we must also accept something even more humbling. We may not be the final chapter. Intelligence might be a repeating phenomenon, a planetary instinct expressed across ages. Each civilization rises, learns, influences its environment, faces challenges it cannot fully overcome, and vanishes, leaving only whispers for the next. These cycles may be millions or even billions of years apart. They may be linked to cosmic patterns, orbital rhythms, geological thresholds. Perhaps intelligence emerges whenever conditions align, as inevitable as the tides. Or perhaps each emergence carries fragments of the last, inherited not through fossils or artifacts, but through consciousness, instinct, and myth. In this perspective, humanity is not the beginning of the story, but another verse in a much older song, a song whose themes echo across epochs, even when the singers vanish. What does this mean for us now? It means the discoveries we make today, comets forming impossible tails, orbital anomalies, isotopic puzzles, are not isolated curiosities. They are reminders that the universe still speaks, still shifts, still interacts with Earth in ways we have not fully deciphered. It means that every time we observe a celestial alignment, every time we uncover a geological enigma, every time we find a fossil that does not fit the expected narrative, we stand at the edge of a deeper truth about our place in history. It means that intelligence is fragile, that memory is fragile, that civilizations, no matter how advanced, can vanish without trace, and that we too may one day be reduced to chemical signatures and fractured geological layers if we fail to learn the lessons embedded in deep time. But it also means something hopeful, that life has a tendency to rise again, that intelligence is not an accident but a recurrent pattern, that every collapse is followed by renewal, every erasure by emergence. We might be inheritors of ancient echoes, continuing a quest begun long before vertebrates ever walked the land, a quest to understand the sky, the earth, and the cycles that bind them, a quest to interpret patterns that stretch across billions of years, a quest to remember what the planet itself tries to tell us in minerals, tides, myths, and dreams. And if we listen closely, if we approach the ancient past not with dismissal, but with curiosity and humility, we may yet discover that the forgotten civilizations of deep time are not gone, but continue to influence us in ways we are only beginning to understand. We may find that we are not the first beings to wonder, to explore, to seek meaning in the cosmos. and we may realize that our survival, our future, depends on recognizing that history is not linear. It is cyclical, fragile, and astonishingly vast. As we close this chapter, let the weight of these forgotten epochs settle into your thoughts. Share this video with those who question, who wonder, who feel that history stretches far deeper than the textbooks suggest, and subscribe so you remain part of this search for what came before us and what may yet